Hey, good morning, everyone. My name is Al Patel. We'll go ahead and begin the IUPS and the I31 presentation. I'm going to go ahead and mute everyone's mics. We'll go ahead and have a question and answer session at the end. If you do have any questions, you can go ahead and post them on the chat. I would really appreciate it. Also, if you can possibly turn off your cameras, that would possibly help with the bandwidth also. All right, my name is Al Patel. I'm one of the strategic accounts manager at Marche Manufacturing, and I'll be presenting on our IUPS product line along with the I31 inverter. So a couple of things that we're going to be covering today. First, we'll go over what a UPS is. We'll come up with a differentiation or comparison between an industrial UPS versus a commercial UPS. We'll go over the IUPS technology and topology. We'll go through some applications and the uses of the IUPS. We'll go over the operating parameters, the standard features, along with the HMI and controls that are on the front of the IUPS. And then we'll go touch on the I31 offering. So what is a UPS? Well, UPS stands for uninterruptible power supply. It provides emergency power to critical loads in the case of mains failure. Provides near instantaneous protection from input power interruptions to the load. The major components of a UPS is basically a rectifier battery charger, which rectifies the AC power into DC and also charges the battery and powers the inverter section during normal operation. The inverter transforms DC power to AC power, typically fed from the battery bank and the power supply to the AC loads. The battery is the energy stored device, which converts stored chemical energy into electrical energy, which provides power to the inverter upon a AC power failure. There's also the transfer switch. This device automatically senses available sources and switches as needed from the AC load between the prime source and the alternate source in case of any power failures. And there's also a manual bypass switch, which is a make before break switch that we provide, and is manually operated. It transfers and switches and used to switch and transfer the load between power sources without any power interruption. So these are the main components that make up a UPS system. The IUPS is double conversion topology. During normal operation, the load is continuously supplied by the rectifier charger inverter combination, which carries out a double conversion of the power, basically AC to DC and then from DC to AC. The double conversion also provides isolation between the utility grid and the load. If there's a power failure, the inverter continues to supply the load using the battery power as a DC source for its input power. Once AC is restored, the charger returns to the beginning, returns to being the DC power source for the inverter's input and charging the battery. And here's kind of a block diagram of that. If there is a failure to the rectifier section, you automatically switch using the static switch to the bypass source and provide power to the load. The inverter section, the charger section is an SCR technology, basically a 12-pulse technology. However, the unique design of the inverter is a PWM control, which is also powered by IGBTs. The output voltage is single phase and a split phase with multiple ratings available, meaning 120, 208, 240. And then for the split, it would be 120 and 240. 1% stability with static load and plus or minus 3% with the dynamic load. The output frequency offered is 60 hertz or 50 hertz as an option, and the stability is 0.05%. When it comes to overloading on the inverter section is actually capable of providing 105% of the rating for 60 minutes, 125% for 10 minutes, 150% for 1 minute, and if it's more than 150, about approximately 200 milliseconds. The output characteristics, for powering the load, THD less than 3% with a linear load and less than 5% with a non-linear load. The power factor is about 0.5, 0.8 lagging and 0.8 leading. The crash factor is 3 to 1. Why use a UPS? Well, one, it's a backup to the load, and two, it's also to improve your power quality against voltage spikes, sustained overvoltage, or even momentary or sustained reduced input voltage, and with remote locations with unstable frequency. Let's talk about the comparison between an industrial UPS and a commercial UPS. The industrial UPS that we're offering here, which is the IUPS, is immune to temperature and air quality, has a much wider range, typically used in industrial processing plants and industrial applications, while the commercial type UPSs are usually installed in a controlled temperature environment, such as a data center. The industrial UPSs are used with backup times of 48 hours or even more, while the commercial UPS are designed to operate a load for 15 to 30 minutes. Because of the longer backup time and reserve time, the industrial UPS offers a larger charger to go ahead and provide power to the inverter at the same time, uh, recharge the battery system. While the commercial type UPSs have a smaller charger because it's got a small battery backup. Industrial UPSs can be used for industrial applications along with IT type equipment or data center type equipment, while the commercial is really intended for a controlled environment and a IT type equipment. And the major thing here is the design life. The design life for IUPS is 15 plus years, while the commercial is approximately 5 years. Within a industrial type infrastructure, most of the equipment there is heavy duty machinery or heavy duty equipment, which usually has a very high design life. At the same time, they want the same type of lifespan on their UPSs. While the commercial side, technology changes a lot more rapidly and the build outs get upgraded or enhanced and usually last for about 5 years. At the same time, them UPSs get replaced. The other nice thing about the industrial UPS, it does provide serviceability, meaning that you can go and service the unit in the field. While the small compact units, when for commercial type UPSs, they're basically a replacement basis. Typical applications of IUPS, oil and gas, oil platforms offshore, power plants, hydro plants, wind power, commercial buildings, and also power generation. The IUPS, the industrial IUPS, comes in a 5K to 60 kVA output rating. The input can be power from a 208, 380, 415, or 480 three-phase input. We also offer a single-phase input option, which is a 208, 220, or 240 VAC with 50 or 60 hertz input. The output, we have a single-phase output, 120, 208, 220, or 240. We have recently also introduced the split phase output option, which is the 120, 240. With the DC bus and the battery connection, we offer a 125, 240 VDC with the range minus 20% up to 18%. And we do have a 3-phase under development right now, and it's planned to be released in the upcoming year in 2024. Some of the standard features of the IUPS include input-output isolation transformer, hybrid design using 12-pulse rectification and IGBT regulation, which also reduces the harmonic distortion to approximately 10% or less. Also includes a 7-inch touchscreen mimic display, includes a battery test feature, which is very important. If you're servicing the system or installing a system, you can ensure that the battery is connected to the DC bus. Also provides web monitoring through an Ethernet port. All the parameters can be displayed using the web browser feature on the IUPS at a remote location or through an IP address. Has alarm dry contacts for local annunciation to a SCADA. Also features a data log. Major parameters of the IUPS are data logged. Has a static bypass switch, battery temperature compensation for the VRLA type batteries with an adjustable rate. Protective devices include AC input breaker, battery breaker, bypass breaker, inverter output breaker. The enclosure is built with an IP20 rating on all these features, and the durability of the IUPS has been tested to the UL 1778 listing. One of the unique features of our IUPS include a shunt for current monitoring and transfer within less than 4 milliseconds. Most UPS manufacturers use a current transformer. We use a proprietary shunt design, which provides a more reliable and precise transfer. The manual bypass switch, which is the MBS, which is a little different than the traditional Marche manual bypass switches that we are all used to. This particular one has a 3-position switch, which is basically the UPS, test, and bypass. When the switch is on the UPS, meaning that the UPS is providing load power to the load. If it's put in the test position, the UPS is actually powered. However, the load is being bypassed through the UPS. The reason for this is you can go ahead and actually do your testing or servicing, making or troubleshooting the UPS while the load is not affected. The bypass is basically a complete bypass from the utility directly to the load. Bypasses the UPS. Here's a black diagram of that. A typical connection would include a bypass source along with the utility power going to the charger, which then charges the battery or provides power to the inverter. And then there's a static switch, and that's at the output of the inverter, which would do the automatic transfer between the UPS and the alternate power, ensuring there's power to the load. We also offer the manual bypass switch and an isolation transformer inside of its own enclosure outside of the IUPS. We have many customers that have requested this, one to serviceability of the IUPS, and also if there is a feature replacement needed, they can bypass the source without affecting the IUPS operation. We'll go ahead and move into the actual display, the HMI. And the HMI is a touchscreen 7-inch display. During normal display, it displays the LED status lights there on the left-hand corner. Also has an on-off switch. Basically, you touch that and it turns up the inverter section on and off. You can also get data logging information. And there's three major tabs here. Um, you can go on, this is the home screen. There's a monitoring screen. There's also a configuration and test tab. And we'll go through them individually in slides coming up. We also display if your inverter and a bypass are in sync, and also the UPS temperature. So this is a very informative 7-inch touchscreen display. Looking at some of the icons that are on the Mimic panel, um, as you can see here, the one in the green here on the top row, you got the utility. Then you have the input breaker that is also being monitored, whether it's on and off. You got the charger, you got the inverter, the battery breaker, the static switch operation, the manual bypass switch. And then for your bypass source, you also have a bypass uh, voltage, the utility voltage, along with the bypass breaker and the isolation transformer. Within the monitoring tab, we display parameters of the utility incoming power. Uh, we provide you with all the voltages, currents, and frequency of each phase. We also provide you with the battery voltage and the current going to the battery and how long it's been elapsed, along with removed amp hours, state of charge. The inverter section, we provide the output power and output current, output voltage and output current, along with frequency and the inverter temperature. The bypass source information, the UPS total output. And then we also provide you with information about the UPS itself, the model number, the serial number, and you can also put in your location and ID as you would like based on the system. Within the configuration tab, that you can go ahead and configure this, including the password. You can go ahead and set your password. There's a default password. You can set it, reset it, and make it your own password. There's also system details, inverter, battery information, static switch operation, communication option. You can set your alarms, your battery alarm, your rectifier alarm, your inverter alarm, your UPS alarm, and the alarms that you would like to be included in the summary. Within the test tab, this is where you can go ahead and test it, each individual alarm relay. You can test them all at the same time, or you can do them individually. You can also do a forced transfer. If you want to go ahead and test, make sure your bypasses will be able to transfer to the load in case of a power failure. Uh, and you can also do your battery test here. We also provide a support tab, information about where they can get support, and Marche's information, our service email, along with phone numbers to contact. As far as the alarm indicators go, there isn't actual LEDs. However, the display does display with a red type circular color-coded indicator uh, where you can go ahead and view all the different alarms that are present and also the status of each alarm. What we'll go through is the actual Mimic panel and the actual operation and how the current flows. During normal operation, you've got the utility power providing power to the inverter along with recharging the battery. And the inverter is providing power to the load through the static switch and the manual bypass switch. Upon a fault, let's assume that there is no power to the charger itself, or the charger has failed. Um, the power would come from the DC battery bank, going through the inverter, through the static switch, and through the manual bypass switch and to the load. If there's a force transfer that's active, which we talked about, that's available on the front main home screen, um, the charger would basically provide power to the batteries being charged. However, the power from to the load would be diverted from the bypass source, going through the isolation transformer, manual bypass switch, static switch, and to the load. If the bypass switch is activated or switched from UPS to bypass, um, it would be basically the same thing. You would have power from the utility through the charger, providing power through your battery. However, your inverter section would be out of the picture here, and all your power would be coming from your bypass source through the bypass source, I'm sorry, bypass switch, and to the output. Notice there is no current flowing through the static switch at this point because everything is diverted and bypassed. Here are the front controls of the IUPS. At the top, we provide you with input-output terminals. Then there's an inverter output breaker. There's a manual bypass switch. There's a bypass breaker, battery breaker, along with an AC input breaker. The alarm contacts are located conveniently right from the front accessible panel once you open up the door. And then there's also a communication module, the web browser that we were talking about earlier, which provides an Ethernet port to go and connect to your computer system for remote monitoring. Here's a complete open door view of the IUPS. This is a larger model. This is a 2-bay model. This is a 40 kVA system. Some of the competitors, major competitors that we have here located in the US along with internationally. The reason why we're bringing this list up is just to make you familiarize with the competition, and anytime you're up requested or inquiry from the customer, if it's a manufacturer of a UPS. Um, there are some that are located here domestically and some that are located internationally. And we provide both types of UPS, industrial and commercial type. The Marche does offer a commercial type UPS also, which is our cups and MUPS product line. But this particular webinar is on the IUPS, and we just want to cover the major components of that and the operation of the IUPS. We have also decided to offer an industrial type or industrial grade inverter system, which goes beyond our other products that we offer. That's part of our product portfolio, our A31. The A31 design, the control ferro design, was limited to about 15 kVA. However, our I31 will go up to 60 kVA. It does come in a 125, 240 VDC offering, and we also provide single phase output along with split phase. And again, we will have this 3-phase output available in 2024. And just go over the block diagram of the I31, the inverter. As you notice, the entire charging section is removed because that's an external component now, and we are only providing you with an inverter that converts DC to AC to power your AC loads. Along with a bypass source, the rest of the system does stay the same. And if you need an external isolation transformer along with an external bypass switch, we can also offer that in a separate external enclosure. That concludes the presentation of the IUPS and the I31. I'll go ahead and open it up to any questions that anyone may have.